Okay, in this video we're going to have a look at alkenes, and alkenes are also hydrocarbons. That means they contain carbon and hydrogen only. They are special because alkenes contain a carbon-carbon double bond. They've got to have one of these double bonds in their structure, and that's what makes them an alkene. Okay, so here's my table. Again, this is in your book that you can go back to. Let's have a go at some of these. Notice first thing, we don't have an alkene with just one carbon because you have to have two carbons in order to get a double bond. So the first one in the family is 2 carbons long. That is called eth, and then the ending -ene to let us know it's an alkene. Molecular formula, let's just leave it as C2 for a moment. Let's just do the structure. So it's a carbon double bonded to a carbon. Then count the bonds, 1, 2, 3, 4, because carbon has to have 4 bonds. 1, 2, 3, 4, and put your H's on to show that it's a hydrocarbon containing carbon and hydrogen only. So you can see 1, 2, 3, 4 hydrogens to make this ethene molecule. Okay. Next one down, 3 carbons. 3 is prop, and then ene because it's an alkene. That means it's got 3 carbons, it tells me. Right, this is how you do a diagram for this. The structure, 1, 2, 3. Notice they're single bonds at the moment. Just make one of them, doesn't matter which one, a double bond. I'm going to make this one a double bond, and then count the bonds. This has got 2, so it needs 1, 2 more. This carbon here, now be careful, you can see it's got 1, 2, 3, so it needs 1 more. I'm going to put that there. And then here I've got 1, so it needs 1, 2, 3 more to make 4. Put the H's on, count them up, 1, 2, 3, 4, 5, 6. So it's C3H6. These two, be careful, they're both bute, so they both got 4 carbons in the chain, but one is called but1ene and one is called but2ene. And the reason they're different, 1, 2, 3, 4. So I've got 4 carbons in the chain. The reason the difference is this. You number the carbons. So 1, 2, 3, 4. So I've got 4 carbons there, as we know, because it's but. And the but1 means that the double bond has to start on the carbon numbered 1. So you can see in my structure, this carbon here is numbered 1. That is where my double bond is going to go. And this means 4 carbons, in position 1, there is the double bond. And you can see I've got position 1, there is my double bond. Then count them up, 1, 2, 3, 4, 1, 2, 3, there's number 4, 1, 2, 3, 4, 1, 2, 3, 4. Put your H's on, and we can count those up in a second. So that is C4, 1, 2, 3, 4, 5, 6, 7, 8, H8. Okay. This one, let's just see how this is different. This is but2ene. Do the same. So 1, 2, 3, 4. 4 carbons in my structure. Number them. 1, 2, 3, 4. And then what I'm going to do is put the double bond this time on carbon number 2 because it's but2ene. So there's my double bond. Now count them up. 1 bond, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Put the H there, and 1, 2, 3, 4. Put my H's on. You'll notice that this is still C4H8, so the molecular formula is the same, but they have a different structural formula because the double bond has moved position. So that's why it's but1ene against but2ene. One more thing to do before we finish is just check these formulas here because we need to come up with a general formula. So it's Cn, hopefully, if you have a look at it, you can spot that it is CnH2n. If C was 50, so we had a long alkene with 50 carbons, then H would be 2 times 50, 100, and this allows you to work out the formula for any member of the alkene family.